Hello, you lovely people. So this is just really quickly going in order of all the changes that I made since I made the last video. This is spring-loaded now, so it can be adjusted on the fly. So I turned it all the way in under load until I heard the RPMs drop, and then I turned it out about a quarter turn more. All right, so you bring it back out until the RPMs go up, and then another quarter turn out, I think is the formula. Anyway, this governor was all the way in this way, and it was maxed out. So I looked down here and realized that the other end of the spring was bent too far up. I bent it down with the generator off. I brought the winding out all, pretty much all the way. And then I started it back up and brought it back in until this read the correct voltage in hertz, about 62 hertz and 128 volts, something like that. That's on a no load. These will be replaced with GFCIs. These are fed by the breaker side of this breaker GFCI that's protecting the 120 volt outlet down here. You can't, even though this has a neutral in it, you can't at the destination use that neutral for anything because it'll trip this GFCI. You really don't have any protection devices like this that cost, this whole unit in here was like 22 bucks. And the box for it was like 15. You don't have anything on the American market or on the world market that takes 240 and splits it into 120, except the American market, and those solutions are really expensive. The 240 with the common neutral, and they cost you at least 100 bucks for 20 amp. So this is a much better, much more cost-effective solution. So at the load side, what I'm going to do is use a Hubble transformer. It's also called Acme. It puts out 500 watts. It'll pull off the 240, and it'll give me a 120 convenience outlet at the other end. And that's why I've marked on here, do not use 120 volt loads on this connection. You can use them over here because these go through the breaker, not the GFCI, and these will be changed out with GFCI outlets. Obviously, the largest change is this 8-inch single-wall duct that pulls up cold air from the floor. So I had to check to see where the studs were, where I'd come out. Then I used a demo saw and one of these. You can pick them up at Harbor Freight to clean up this hole. And I'll put some 1/4-inch hardware mesh in it. And then I'll push this back down in the hole and secure it with a couple of studs on either side. It's not going to get hot, so I don't have to worry about heat and stuff. And that brings cold air in here. And the battery's been moved down there, so hot air isn't hitting the battery.